We're going to look at Pearson's product moment correlation coefficient, and we're going to compare it to Spearman's in these two questions. So this is a very classic stats question at GCSE, where you will be given a Pearson's rank and a Spearman's rank, and you'll have to comment on them. Now, firstly, let's just get one thing clear, that Spearman's and Pearson's use exactly the same rank. All right, so let's draw the range of values that Pearson's and Spearman's can use. So it's going to be between -1 and 1, with 0 in the middle. So Pearson and Spearman's use exactly the same range of values. They can only be between -1 and 1, where 1 is strong positive correlation. 0 is no correlation. And -1 is strong negative correlation. So the only primary difference is that Spearman's is related to all types of correlation. So, for example, Spearman's rank can also evaluate non-linear correlation. So let me show you an example. So here we would have, I'm going to plot some points. Let's do points like this that have a very clear curve. Now, Spearman's rank for this, although it's not perfect linear correlation, you can't draw a perfect straight line through this, Spearman's rank will still be quite high for this. So Spearman's rank could be like 0.86 for this, because you can draw a curved line of best fit that goes through all of the points. So it's going to be positive because it's going as one variable is increasing, the other is also increasing. And because you can draw a pretty effective curve that cuts through most of the points, this Spearman's rank is going to be very close to 1. However, the Pearson's rank for this example will be less than that because you cannot draw a perfect straight line through the points. So Pearson's rank for this one might be 0.67. So it's still positive, but I'm going to draw a straight line through. I'll use a different pen. I'm going to draw a straight line through this. It might look something like this. All right. So most of the points will be close to the line, but unlike Spearman's, where nearly all the points touch the line, some of them touching the line and some of them are quite close but not quite touching. So you can tell that that Pearson's correlation, which is in black, isn't going to touch the line of best fit isn't going to touch as many plotted points as Spearman's would, because Spearman's also takes into account nonlinear correlation, which includes curved lines. So that's the primary difference. Pearson's rank is interested only in linear correlation, and Spearman's is interested in all types of correlation. All right. So if your Spearman's rank is high, it means there is correlation, strong positive correlation. However, we're not sure if it's going to be a straight line or a curved line. Whereas if Pearson's rank is close to 1, we are sure that it's going to be strong positive linear correlation, where it means straight line, where all of the points are touching that straight line. Most of the points are touching that straight line. So with the differences outlined, let's look at some of these questions. So question 1, Jason is investigating the relationship between the amount of fertilizer used, X, and the weight of his tomatoes, Y. So it's trying to work out whether or not using more fertilizer is going to have an effect on the weight of his tomatoes. And the scatter graph shows the information. So you can see here the line of best fit. If it was going to be linear, a lot of the points won't be touching the line. Whereas if you have a curved line of best fit, quite a lot of the points would be touching the line. Jason calculated two correlation coefficients, so he's calculated Spearman's and Pearson's, and then here are some possible results. So you're given options of what they could be, and this question in this revision guide has given you the answer for Spearman's. So we've said Spearman's is 0.85, and we have to work out what Pearson's would be. So I would say for part A that Pearson's is going to be less than 0.85. The reason being is because remember, Spearman's takes into account all types of correlation, and you can see you could draw a pretty nice curve there where most of the points would be touching, which means that it would be quite strong positive correlation. As the fertilizer used increases, the weight of the tomatoes is increasing, so there is a strong positive correlation for Spearman's. However, for Pearson's, you can still get some positive correlation if we're going to draw a straight line through this, but not all of the points will be touching it. So it will be less, Pearson's will be less than Spearman's, and I would say it's going to be still positive correlation, so I reckon the sensible answer would be 0.65. Not as big as Spearman's, which is taking into account nonlinear correlation, but still positive, so it's going to be 0.65 as your answer. The reason that my answer to A, I have to explain it, is I would say Pearson's product moment correlation coefficient, or PMCC, is less strong as it measures closeness to a linear model. Now, you don't have to write this word for word. If you say something like Pearson's measures linear correlation, and this the points sort of create a curve. If you say something to that effect, you would get the marks. So you'd say PMCC is less strong as Pearson's is less strong than Spearman's, because on the graph you can see there is a curve. Non-linear correlation is stronger than the linear correlation, something to that effect. But basically, you're saying Pearson's is less strong because it measures linear correlation, which won't be as great as the non-linear correlation. That's the first question. Now, question 2, a closed shop manager records the weekly sales figures and average weekly temperature in degrees centigrade for 6 weeks during the summer. So, as you can see, as the temperature is increasing, the sales from the closed shop is decreasing, and there's a slight curve, but not a great curve. The manager works out two correlation coefficients as negative 0.87 and negative 0.9. I'm going to complete this table. So for that was question 1, here's question 2. For 2A, I would say Spearman's is going to be slightly larger than Pearson's. Or I should say slightly closer to negative 1 is what I mean, because negative 0.9 is technically smaller than negative 0.7. What I mean is Spearman's will be closer to negative 1 than Pearson's will be. So I'm going to say Spearman's is going to be negative 0.9 and Pearson's is negative 0.87. The reason for this is that you can see, looking at the graph, that if you're going to draw a curved line of best fit, nearly all of the points would be on that line. Whereas if I draw a straight line, a linear correlation, which would be to do with Pearson's, then you would only have the majority of points would be touching the line, but not all of them. So Spearman's is going to be closer to negative 1 than Pearson's, because if you draw a curve, you're going to include more points on the line of best fit. So then we have to justify our answer, and for reason B, I'm going to move it past the shadow. For reason B, I would say the graph is not a straight line. So Pearson's product moment correlation coefficient will be further away from negative 1 than Spearman's rank. And those are the two questions answered. So basically what you have to evaluate in these questions is there a curve? And if there is, then Spearman's is likely to be the number closer to either 1 or negative 1 than Pearson's, because Pearson's is only interested in straight line correlation. And that's most of the time, that is what you're being asked to talk about whenever you're giving reasons. And so if there's a curve, Spearman's is going to be closer to 1 or -1 than Pearson's. And that's effectively all that Pearson's is asking you to talk about in those sorts of questions.